Hello once again. So I wanted to make a little video just with the first one or two examples in the notes, just so everyone found their footing okay with the start of the straight line notes. So we're going to talk about the gradient formula initially. And to work out the gradient of a straight line, it's just a single formula, a single fraction. We look at the change of the y ordinates and we divide it by the change of the x ordinates. Right? So x1, y1 is a coordinate and x2, y2 is just a different coordinate. And we've got exactly that situation in example 1. We've got these values here. We've got the 0.15 and we've got the 0.414. So I'm just going to draw a little diagram for that. This is very much a rough diagram. All I'm really considering is like their relative position. So 414 would be a little bit further across and quite a lot higher up. And I'm going to draw what's probably going to be a wonky line. Yeah, it is a bit, to join them together. And I'm going to make a right angle triangle out of this. There we go, nice. So here is one of the coordinates. It's got an x part and a y part. And here is the second coordinate. It's got an x part and a y part. So if I put all of this into the formula, y2 take away y1 divided by x2 take away x1, I'm going to have 14 take away 5 on the top of my fraction, and I'm going to have 4 take away 1 on the bottom of my fraction. So this is going to work out as 9 over 3, and 9 divided by 3 is 3. So the gradient of my straight line is 3. All right, let's have a look at example 2. This one's going to involve a little bit more algebra. I'll just sort of outline the plan of action here. The line that passes through 3, 7 and 1, 11. So what we're going to do is we're going to find the gradient first. And then we're going to use the straight line equation, which is y equals mx plus c. So that's the plan of attack. Now, I haven't got a space to draw a diagram here, which is a shame. So I'm just going to squeeze it in on the side somewhere. Let's get a little box. There we go, here will do. All right, so 3, 7 and 1, 11. Let's just plot where they would end up roughly. So 3, 7, if that's, I don't know, if let's say that's here, doesn't matter really. 1, 11 would be slightly to the left and slightly higher up. So the reason why it's useful to do this is when you start joining this up, you can start to think about and start to spot certain things, like this is clearly a negative gradient, so I'm expecting to get a minus answer out here. All right, let's plug it into the gradient formula once again. So those are my points. So if I do y2 minus y1 over x2 minus x1, I'm going to get 7 take away 11 divided by 3 take away 1. And this is going to give me minus 4 over 2, which is going to give me a gradient of minus 2. Just so you know, if you wrote these x1s and x2s the other way round, it shouldn't make a difference. What will happen differently is the signs, rather than the top number being negative and the bottom number being positive, it'll happen the other way around. In terms of the eventual answer, it won't make a difference. Now, a little bit of algebra that we're going to do here. We know that the formula of a straight line is y equals mx plus c. And we just found out that the gradient is minus 2. So we can replace our m in y equals mx plus c with a minus 2 and we can get that out. Now, from here, we don't know what the intercept is, but we do know that the point 111 is on the line. 1 is the x value, 11 is the y value. So what I'm going to do is I'm going to substitute in 1 for x, and I'm going to substitute in 11 for y, and I'm going to see what I get. So instead of y, I'll have 11. Instead of x, I'll have 1. And then the only letter left over now is c. And if I solve this, I'm running out of space. let's check it up here. 11 plus 2 is going to give me 13, which is my value for c. So the equation of this straight line, which I've run out of space completely for, so I'm going out of the book completely. You probably still want to write yours in the book. Y is minus 2x and c is 13. There we go. There's the formula for the straight line there. Ta-da!